Welcome, everyone. Thank you very much for coming. This is so you're part of an experiment here. This is our first Make It OSU event. My name is Don Rucker. I'm the Associate Dean for Innovation at the Medical Center and on the Faculty in Emergency Medicine and Biomedical Informatics, and part of the Idea Studio, which is the sponsoring organization here along with the College of Engineering. This is an event we put together with Scott Osborne from the College of Engineering. He's right there, and you'll hear from in a second. Basically, so I'm actually new to Ohio State. I came here about a year ago. And, you know, one of the things that appealed to me about Ohio State is the vastness of the resources here. And, you know, Scott and Randy Moses, we were talking about how do we get some of the vastness of the engineering resources, I mean, the excellence in engineering, all the National Academy of Engineering winners. It's a great, great environment. How do we get that into the life sciences? A lot of docs, a lot of life scientists are, I think, folks like me who've actually never had an engineering course, or maybe very little. And so we decided to do this as an introduction here. And we're really going to run you in rapid fire through sort of a whole stack of engineering things, from how do you think about industrial design and building a product, what the product design components are, what materials do you use, and then some of the core technologies, some of the nanotechnologies, which are obviously up and coming, sensors, microfluidics, all of those types of things, you know, the plastics. So that's what we have for you today. The logistics are pretty simple. We have a break at 3:30. There's stuff in the back to munch on. We'll have a formal reception with more stuff at 5:30, so nobody will leave here starving, at least not because of us. And I think our big challenge will be we have such great speakers and such a great agenda, keeping everything into that 20-minute time frame. So with that, let me introduce Scott Osborne, who has done a heroic job in putting this event together.
Thank you, Don. On behalf of the Dean of the College of Engineering, Dave Williams, and the Associate Dean of Research in the College of Engineering, Randy Moses, I want to offer you a welcome and greeting. Thanks for coming today. I'd also like to make a pitch to say the College of Engineering would love to work a lot more with the College of Medicine and the health system here at OSU. I also want to thank all of our speakers today. We're really fortunate to have a great selection of Ohio State University faculty, but we also invited some local industry partners to come in and share out of their areas of expertise. So I think you've got a real nice diversity of speakers today. They have all been asked and explained to in great pain that they have 20-minute segments. So they'd like a lot more time, but they're going to do their best just to give you the headlines of their areas of expertise, because what we really hope will happen today is that all of you will, a light bulb will go off, and you'll recognize that there are some existing technologies and capabilities that could be applied today to help you bring your medical device ideas to life. So with that, let me introduce our first speaker, Reinhart Booter, who is Professor Emeritus of Industrial Design in the Department of Design here at The Ohio State University. So we're pleased to have him speak. Reinhart, please.
So you're going to turn this on here? Okay. I have the honor of being first. And I guess it has to do with the fact that I promised to give some kind of an overview of the R&D process or the development process of primarily medical devices. That goes from the very early idea. I called it a great idea, or maybe the greatest idea that you may have, to the point where the product may eventually hit the market. Now, all of this in 20 minutes, you can imagine that will take a little effort here, and if it's too fast, I'm sorry, I didn't make up this agenda here. Those of you who haven't grabbed one of the sheets that I put at the end of each of those table rows should do so, because I prepared not a PowerPoint, but a handout, and I want to go through this very briefly. And should you have any questions, I am more than happy to answer those, maybe during the break or in whatever way you prefer. The handout that, as you can see, looks as if it is a linear process that I'm talking about. And in reality, that, of course, is rarely ever, if ever, the case. Every situation requires its own way of going about it, but most of the different steps I delineated are in some way to be overcome, conquered, dealt with, although the order sometimes may change. And what Blaine Lilly just, you pointed just out, it is that linear process is in no way indicating the time it takes. Just for instance, should you ever hit the FDA, we're talking about as long as years to get something done. So the process is basically a great abstraction. I speak from experience because my research was and still is in the area of semantics, which is the study of meaning. And since that can be applied to just about anything, I, more or less by accident, applied that to transportation. I worked with the Center for Automotive Research for many years, developing interiors and interface systems and things of that nature, and to medical device development. Starting out in the, must have been the early 70s with IBM Biomedical Systems, and then through some unexpected connections, got into medical device development, which I did as a consultant for many, many years. And the chart that you see is reflecting my own experience working with startup companies, primarily in the Silicon Valley area. I hope that what I will be going through is of some interest to you. I felt that most of you will probably wonder how an idea becomes a reality before you deal with some of the more intricate details that will also be presented here today. So, looking at my watch here, let me go through that chart, which kind of looks like this here. So you should have this in front of you, or you don't really know what I'm talking about. So it starts with, let's say, an idea that you may have, that you observed, some kind of a need, something that was brought to your attention, and that looks like it could be improved. My own experience says that you hardly should ever fall in love with your own ideas, because it may be something that nobody else is interested in. So I forbade my students to actually fall in love with ideas, because it closes the mind, and it focuses on something that may or may not be that important. I also feel that one couldn't start early enough looking at patterns that may already delineate in some way the idea that you have. So the earlier you know that it is a unique thing that you're dealing with, the better. I also found it very useful that you check your idea with stakeholders. Stakeholders are not just the users, the surgeon or whoever is at the end of the product line once it is being applied, but with all kinds of people that may have an interest in the success of your product. One being hospital administrators that actually buy products in bulk for you to use. So anybody who is involved in some way, colleagues, administrators, nurses, technicians, should be checked in some way as to the validity of your idea. It may be wise at this point to have some kind of a confidentiality agreement, because there are these bad people out there that benefit from wonderful notions that you may have, and may even get a little faster towards the end of it and then beat you. So a confidentiality agreement could be a simple one, will protect you from your initial idea to be abused. My third point that I'm making here is looking for funding. Now that sounds maybe simpler than it is, but having worked with venture capitalists for many, many years and startup companies, I know that it is a constant struggle to keep funding alive and going. So in our case here, we have a group that may or may be of help, the Technology Commercialization Office on High Street, and called TCO, and they may or may not be able to help you finding some funding or connecting you with possibilities. There are different ways that you might be more familiar with than I am. The next step would be to, I call it breadboard modeling. This sounds like a funny term, but it is actually used in the industry. It is something that looks like a contraption that works in some way, but is a far cry from looking like a device that could be handled by anybody. Usually I'm personally brought in at that level as an industrial designer, and I can assure you that more than one time I was scared at this point, seeing these tubes and all kinds of little motors and other things sort of being laid out on a table, starting to pump and work, and then all of this has to go into a handle of some sort or into some easy to understand system. So at this point, I'm brought in as an industrial designer because I am usually hired to make some comprehensible sense out of these contraptions. And there are also design firms out there that would help you with this. And since I don't have any PowerPoints, I brought a couple of things with me that are a little difficult to see from a distance, but maybe I can later on put the material on the table. Nowadays, and you'll be hearing about it from Blaine Lilly, I guess, things like this are being 3D printed. But these are a little older and are made out of foam. And it just shows that there is never just one way of putting an idea into a form. There are many different ones. And so the first effort that designers are getting involved in is showing some of the variety of directions that this idea could go. The result of those first concept generation are sometimes good enough to be patented. Again, a patent couldn't be found early enough. This is not just a patent search. This is the actual formulation of the patent, which involves quite a bit of effort, also money, and maintenance eventually. So a patent is something that is absolutely crucial. And again, something like the TCO, the Technology Commercialization Office on High Street here at OSU, may be of help with that. Once a particular direction is being found and maybe even patented in principle, there is usually some detail development necessary. And at this point, one direction is being picked. In this case, it was a skin stapler and a somewhat more solid model is being developed, or a whole range of it, number taken out, evaluated, because there are different angles and different ways of detailing such an idea. I think I have a few sketches here normally, and nowadays those sketches, which are basically just a way of putting it into the computer. Nowadays, back then we just put it on paper, will lead to something a lot more one-directed, I should say. And there are different ways they could become. A second generation would look like the real thing almost. So it could even work to a certain point, if necessary, just to find the most convenient, the most ergonomic way of deciding which way to go. Again, those models can be evaluated and tested and have to. And again, maybe the FDA is beginning to get involved at this point. The earlier the better, because the process as such takes a long time. The legal approving by the FDA, or if the device is considered for export or use in other countries, there are equivalents of the FDA in Europe and Asia, and that could make the process even more difficult. After the legal approval, and sometimes in between or parallel, there are of course, the engineering details. I think I have a couple of examples here that look like drawings. Well, there is no way around getting into some of the details that you may or may not have seen in terms of even tolerances and so forth, material selection. That usually leads to first run of parts. Again, again today this can be printed, 3D printed, a lot more easier than it was in the past. And finally, there is going to be a production run and an initial one, and there is packaging, and there's all kinds of other steps in between. But once you get to this point, you just about have it made. I have a few different products that I was involved in over the years. And one of the companies, Atracure here in Cincinnati, finally developed this product. This has a lot more curves nowadays because the computer does this so nicely. When I started in the 70s, it was the easiest thing to draw a straight line. Engineers loved that kind of a design, and so we tried to make them happy that way. And there is nothing wrong in many cases to go to a pretty straightforward design instead of making something that is complicated. So I guess I made it through in 20 minutes. Hopefully you have a lot of questions that can be asked later on. But at this point, I guess I want to make sure that my successor has the time he needs to get his point across. Thank you very much.